My name is Frederic Huve. I'm working from HP. I'm a chief architect in the CMS organization, and I'm going to show you a demo about virtualized network platforms over IMS and VoLTE networks. So today the goal is to demonstrate HP products and how they work over virtualized environments and also over the NFV and what are the benefits brought by NFV for such telecom software solutions. So now I'm going to show you the presentation, and then we'll see the live demo on the system that are running in France in a data center. So here our presentation is about how we can modernize the value-added services that we're running in the telco network when moving over IMS and LTE kind of new networks. So in the past you have telecom application running on dedicated hardware, okay? And each application has its dedicated hardware. Now, thanks to the virtualization, all the telco application like IN platform, IVR, audio video conferencing system running an HP solution can run over a virtualized layer and a common infrastructure. Now with NFV we are going to see the benefits that the communication service provider can leverage. Here you see that the HP solution has been designed to be a VNF, a virtual network functions, that is integrated with the HP NFV director. So you see that the NFV director is controlling the virtualization layer. We support KVM, VMware, and the IaaS infrastructure like HP Cloud System Matrix or OpenStack. And below you have the compute, storage, and network resources. Here the use cases that we are going to show is first how NFV can help to provision and deploy a new telco application like IVR, telecom application server, in hours rather than days or weeks that we had in the past, thanks to the integration with the NFV director. So here you see that both telecom solutions, here and here, are completely integrated within the HP NFV director orchestrator. So, and the deployment has taken 1 hour compared to 1 day or 1 week that we did in the past. The second set of use cases are around the elasticity, okay? And how manual elasticity and automatic elasticity can help to, in real time, match the supply and the demand, optimizing the infrastructure, but also optimizing the power consumption of the underlying infrastructure. So in the demo, you are going to see the HP Telecom Application Server running over the virtualized environment, VMware, KVM, and you are going to see the multimedia services environment from HP, the HP OCMP as the MRF, and the HP Multimedia Service environment that is playing the role of the multimedia application server. All of that, they have live monitoring that you are going to see, and they are integrated in the NFV director thanks to the VNF manager from provided by those components. So our telecom application server, you can see here, is loaded in this environment and is taking calls, acting as a telecom application from the network, and can, in real time, change the signaling protocols and in order to make this translation. So here, see that we take some call from the telecom application server. Now we are going to focus on the multimedia services environment with the dynamic elasticity. So in this environment, the goal is to, as I said, to match in real time the supply and the demand. So if the traffic experience a peak of traffic like this, you have an alarm, and the alarm is sent to this element manager from HP. The element manager automatically is going to ask for a scale-out operation towards the NFV director using the OpenStack APIs. So in real time, we are going to add a new MRF instance in the cluster. So I'm going to start some traffic here, and in the same time, I'm explaining. So here we are starting some SIP traffic, okay, emulating IMS or LTE networks. So you see that, you see a green and a red curves showing the traffic taken in real time by the multimedia servers. What is going to happen here? Here we are sending some traffic. The traffic is spread across the multimedia cluster. See here, green and red. If there is an increase of traffic, we'll get an alarm like this. The alarm is sent to the element manager of the VNF. and then automatically we are going to scale out to activate a new server, like this server. And this server is going to be added automatically in the cluster to handle the load dynamically. So here you see the traffic. I have one server here that is stopped, is provisioned in order to be ready to take this extra peak of traffic. So here I'm going now to simulate the peak of traffic. I'm increasing the traffic. Here, 6 calls per second, you are going to see. So here we are going to get a peak of traffic. You have the peak of traffic here that occurs, and now we are getting the alarm here saying major, too many calls on this cluster for this VNF, so scale out a new VNF component for this VNF. So we are going now to add dynamically this instance in the cluster, and you see that it was stopped, and now the server is ready. It has been activated to dynamically take the traffic. So now we are going to see that here in less than 3 minutes the blue line is going to increase, meaning that the server has been completely activated, started, and is added to the cluster. So this is really this operation that we are going to see in real time. Now, what's going to happen next? When the peak of traffic is over, like here, so when the traffic is decreasing, this peak is decreasing here, you are going to reach below a certain configuration parameter, a low water mark, meaning that the alarm is going to be sent to say, okay, the peak of traffic is over, is completed. In that case, this alarm is captured by the element manager of this VNF, and the rules that is executed take the decision to scale in, to remove this cluster, this element from the cluster, because now there are no need. The peak of traffic is completed. So what's going to happen here is that you have the traffic with the 3 VNF components in this VNF. You have less traffic, the peak is over. We will get the clearance of the alarm. This alarm is interpreted by the element manager, the VNF manager of this VNF, and then automatically a deactivate command is sent to the element in order to be stopped gracefully. So to avoid to lose any calls, stop, remove them from the cluster, and then completely remove from the VNF cluster that you see. So deactivate command, and it's completely removed. The takeaways of this demonstration from HP is really that for the value-added services that we have in our network, we are really focusing to help our customer to innovate, converge, and consolidate. The innovation is really by opening high-level APIs to our CSP to develop new kind of application, but also to support new protocol and architecture like WebRTC that are key today to combine IMS traffic, LTE traffic, but also to take the traffic from the web community in order to make multimedia interactive calls and sessions. The second point is around the convergence. Have you seen that we have a converged environment for both telecom, IN, and SIP and diameter application, and also for multimedia services environments with MRF, playing the role of IVR, audio conferencing, video conferencing, and multimedia interactive conferencing application. And finally, the consolidation, which is on top of this NFV, to abstract the telecom application from the underlying layer, but also to allow to benefit from the NFV. And the NFV in such context brought, as I said, 2 main real advantages. One is the rapid introduction of new services and the rollout of existing services. Okay? And the second one is to match in real time the supply and the demand, to optimize the power consumption and also the infrastructure. Here you have seen that automatically the MRF start to take gradually some calls, and now is going to take the calls completely and to balance the load within the cluster, meaning that the load is going to decrease. Okay, you're going to see that. And after this, we'll be able to scale in. So this is the key message that we would like to show and to demonstrate with these HP products and solutions. So have you seen the VNF has been scaled out automatically in this cluster? So it works, it's deployed in our HP data center. So I hope that you enjoy the demo. We'll be happy to see you again for more demos from HP. So the most difficult question we get mainly from the business or sales guys are really what are the real cost saving for the CSP moving to NFV with this kind of value-added services application. So in our side, it really depends on the customer deployment, the network, the maturities, on the virtualization steps and process. But really with the NFV, we hope that by in real time matching the supply and the demand, we can really optimize the power consumption. And we can probably optimize the power consumption by 20 to 40% depending on the infrastructure, but this can be a very huge gain just for these value-added services applications.